All right. Working on section 5.3, the last one in the course. Method of shells. We got x squared, y equals 0, and x equals 2. This is going to look very familiar to you. Y equals x squared, we know goes through 1, 1, and then 2, 2, 3, 4. X equals 2 is the vertical line at 2. Y equals 0 is the x-axis, so we're talking about this region right here. And we're going to rotate that about the y-axis this time. So we're going to get our mirror image. And this is a shape that we've looked at once or twice before, depending on how you count. This is the shot glass that we found when we rotated the square root about the x-axis. So we already know that the volume of this should end up being, it was either 8 pi or 4 pi, I can't remember, one of the two. But we're going to use the method of shells this time to find it. Remember, the setup for the method of shells is 2 pi, the integral of x times f of x dx from a to b. And the a to b comes from the region that you're rotating. Okay, so the region that we started with is right here. And if you pick a representative rectangle, just one rectangle from our division there, all the information that you need is contained in that. So we got 2 pi. Our region starts at 0 and ends at 2. Okay, so it's where the region begins and ends that determines your limits, not from where the shape begins, right? That would be -2 to 2, and that would give us a problem. I'm not really sure what that would do, but it wouldn't be good. X, remember, was the radius of the shell. It's the distance from the y-axis to the shell, but for us it's always going to be x. And then the height of the shell is f of x for the top curve, and you can think of 0 as the bottom curve. So that's just going to be our f of x, which is x squared in this case, dx. Okay, so 2 pi, get your a and b, x times the function dx, and we end up with 2 pi integral 0 to 2 of x cubed dx, which is easy to evaluate. This is going to give us x to the 4th over 4. And that's from 0 to 2. So all we have to do is plug in a 2. 2 to the 4th is 16, times 2 is 32, divided by 4 is 8. So we end up with 8 pi there, which we knew from the beginning, from having done it before. Right? Look at the next one. Y equals the square root of x. Y equals 0, x equals 4, about the y-axis. So if we go 1, 2, 3, 4, and the square root's going to be 1, 1, and then 4, 2. So we're looking at this shape again, and y equals 0 is the x-axis. So we're looking at the shape that we rotated about the x-axis to give us the bullet previously. This time I'm going to go about around the y-axis. So we're going to get our mirror image over here. And then I'm not sure how to think about this shape. What we have is, I like to think of it as that big plastic volcano-looking thing that you see in the mall. You drop a quarter in it and it spins around and around and around till finally it drops down in the middle. So shape kind of like that. Pretty big volume now because we get a lot of solid space here rotated around the axis with a fairly small hollow in the middle. If we think about our typical rectangle and how far it is from the axis, and think about our original region that's being rotated, our setup is going to be 2 pi from here to here, which is from 0 to 4, the radius, which is x, times the top function minus the bottom function, so square root of x minus 0, which of course we don't need to write, dx. That's the thickness of the shell. So that's going to be 2 pi 0 to 4 of x to the 1 power plus 1/2 power, so that's going to be 3/2 power. Now x to the 3/2 power, the antiderivative will be x to the 5/2, and then we'll multiply that by 2/5 from 0 to 4. Oh, sorry, that's sloppy. And then we can simplify this. That's going to be 4 pi over 5. And 4 we put in here. The square root of 4 is 2 to the 5th power is 32. So 4 times 32 is going to be what, 128 pi over 5, or 128 over 5 pi. Now, sometimes I forget to guesstimate these ahead of time. I did on both of these. The last one, we knew what we were going to get. Here, if we were to have guesstimated, the radius is 4, the height is 2. So we would have gotten pi times 4 squared times 2 equals 32 pi. Right? That would have been the volume of the entire thing if it wasn't hollowed out in the middle. 128 divided by pi is about 25.6 times pi. So that's less than 32 by not all that much. There's not all that much hollow space. So I'm happy with that result. I'll see you next time. We'll do a couple more.